Yeah, but at YouTube I can see nothing.
Yes, sir. We are live now. Please start.
Okay, good afternoon, folks, everyone. Thank you so much for logging into our live session or webinar. For the first one for this course, technology forecasting for strategic decision making. We are very, very happy to be here, meeting you through this medium. And I am Bala Ramadurai, professor of a professor of design thinking and technology forecasting as well. And with me, I'm very happy to say that I have two other folks who I'm happy to be, working with. Is Professor Dmitry Kucharavi from logging in from Strasbourg, France, and Siddharth from Vishakhapatnam, who is going to be our teaching assistant for the entire duration of the course. So I let them introduce themselves. And Professor Dimitri, over to you. We are very happy to have you on the course.
Good afternoon or good morning. It depends where from you are connected. I'm really happy to have this opportunity to share with you today some knowledge about technology forecasting for answering your questions. And for me, the main target of today's session is to receive your questions and to help you to get the answers for your questions. So probably Siddharth is going to introduce himself.
Good afternoon, everyone. Welcome to our live session on technology forecasting. I am Siddharth and your teaching assistant for the course. By all means, please, we want this session to be as interactive as possible. So we are hoping you could ask your questions on our live chat or at the discussion forum. And Professor Bala and Professor Dmitry will be very happy to answer your questions. And very quickly moving on to our session, Bala sir. Over to you.
Okay, thank you so much, Professor Dimitri and Siddharth. It's as always, it's a great pleasure to be working with us. And we're hoping you guys with your questions will make us think. I really appreciate students who make the professors think, and that's enhances our own knowledge. Plus, if it's of use to you and it helps you in your furthering your career if you're working for a company, or if you're a master's student or a PG or a PhD student, or you're learning because you were so curious about technology forecasting, you really want to find that out. We'll be more than happy to help you out. This is something that we love to bring you, make things clear for you. We did our best to convey what we had in mind through our videos, week one that you have just watched. If you have not, it's live and the assignments are due in case you're taking the course for a certificate as well. So without further ado, I would like to start off with we have this is the format that we are going to follow in this live sessions, is that we'll have a mini topic of interest within the purview of the course itself, which is of interest to us, as well as it's got its relationship to the technology forecasting and strategic decision making also in that ambit. Okay, so we will give you some kind of teaser material to get you interested in the topic as well, so that you can take further. Of course, if you have any questions at all during this 1 hour or any time during the course or even after the course, use the discussion forum, use these live meetings, and we have also announced the schedule of this meetings also on our website. I think roughly we have 4 of them total, including this session. We have 4 of them, so we have 4 chances to meet you and folks to clear out anything that may not be clear to you, or any thought that comes to your mind also. So with that, I would like to request Professor Dimitri to share with us this exciting topic that we have discussed about. We're all curious. What's this all about, Professor Dimitri?
In fact, if you watched all the video for the week number 1, you've seen several concepts and several definitions, but the key concept that lie on the foundation of reliable forecasting, this is a concept of limiting resources. In fact, the main idea of the methodologies that I try to develop since 2004 for reliable forecasting of technologies, and which I tested in several industrial and research institution projects, the very basic idea is that if we know what are resources limiting evolution of certain technical system or certain technology, we can predict what will be the replacement of this technology and how the technology will substitute each other. So that's why I would like to just to come back to something that you've already seen within this week about limiting resources, and I would like to introduce you the book from which my journey started in this direction. And this book, in fact, was published years ago, to be exact, somehow in 70s, in the 1970s, and the book was named The Limits to Growth. And in the time of publishing, this book made a lot of controversy and discussion all around the world, because in this book, the researchers from MIT, they didn't make any forecast. What they did, they built a model in order to simulate how evolution goes in a time. And what they found was interesting from many points of view. But let us see step by step. First of all, what is it? This book was published, and after that, 5 or 7 print was reprinted within a time, because it grew up a lot of interest all around the world. As you see now, we can see from perspectives about 50 years, so we can see how it was from point of view of forecast and reliability of this forecast. The Limit of Growth was compiled by a team of experts from US and several countries. It was not only from MIT. What they did, in fact, they used system dynamic theory, which was suggested by Professor Forrester. And about this system dynamic, you will see some details after from Professor Bala, Ramadurai. And they built the model, which they named World 3. And the book presented and analyzed 12 scenarios that showed different possible patterns and environmental outcomes of the world development over 2 centuries, from 19th to 2100. And now we are exactly in 21st century, and exactly we can see how the outputs of those modeling and how the outputs of those calculation was real and not real. The World 3 scenarios showed how population growth and natural resources use interacted to impose limits on industrial growth. And industrial growth, this is exactly our topic about technologies. The industrial growth, we care a lot because, in fact, we satisfy the human needs mostly by technologies. And the technologies, they are absolutely directly linked with industrial growth. And some ideas were suggested in this book. How can we do it more wisely, spending the resources? From point of view of forecasting, for me, it was really astonishing, because I took this book in my hand first in 2003. And in 2003, I saw that what was predicted 30 years ago, what was calculated, in their books, we need to understand, they never wrote that they made prediction, okay? They always said, this is a model that we run in order to understand how it will go and in order to play the difference. But for me, it was very astonishing to see how it was exact. how it was exact. But let us see the story of publishing of these books and updating of those findings. In fact, the first version of the book, The Limit to Growth, was first published in 1972, and several reprint until 1974 we can find if you look through the Amazon, for instance, or through the other libraries. It seemed that there were a lot of controversy and a lot of discussion. In 1992, the same team of researchers, they published another book 20 years later, because in 90s they saw that something that was calculated before, the expanding of the resources in worldwide scale was alarming, and they published the book Beyond the Limits. It means they tried to see the scenario, what will happen if the limited resources we spent even more aggressive than it was calculated in the book 1972. In 2000, the third version of the book was published, Limits to Growth. And in this book, the authors, the team of authors, the same team of authors, they tried to sum up what happened and what did not happen according to the calculations suggested in 1972. And one of the interesting conclusions that nothing that had happened in the last 30 years has invalidated the book's warnings, because in the book 1972, they raised several warnings about pollution in particular, about issues that we are facing today, which are very challenging for us, as soon as we try to answer them mostly from technological point of view. It happens that one of the author of this book passed away in 2001. So that's why there will not be any book like that in 40 years after and so on. But one author, because three co-authors was the core of this publication, one of them published the book which is named 2052. And Jordan Randers, who participated also in the development of results of 1972, he tried to make projection 40 years in advance using the same models, the same approach. But here he is talking really about forecasting. And if you are interested about topic of forecasting and how system dynamic can be applied, I strongly recommend this book, and I suppose now it's available in the libraries. It's not so fresh, okay? It was published in 2012, but this book really can help you to be familiar with the concept of limiting resources. And if you are interested about the book 30 years, of course, it can be found in the library, but in the internet, you can find the synopsis of this book, which is named Limit to Growth. Okay, you can search it and you can find as a PDF file. It is a short sum up of the book. Of course, our famous source of information like Wikipedia, there you can find a lot of you can in Wikipedia you can find the story about this book. You can find also the positive review, a legacy, and something that, for instance, in 2016 report which was published in United Kingdom concluded that there is a unsettling evidence that society is still following the standard run of original study. So from point of view, of course, of technology forecasting, this particular book for me is interesting to share with you because it shows us the very bold idea that forecasting is possible. Forecasting, calculation is possible because most of the people who are even interested about technology forecasting, they believe strongly that to forecast future is not possible. Why it happens like that, we already discussed in our video and we are going to discuss within our course, but we are going also to suggest you some tools for that. Let me show you the essential part of this book, which was published in 1972, and probably it will help you to build a bridge with what Bala is going to show you. In fact, now on your screen, you can see the model, World 3 model. This is how it looked like in graphical representation. Okay, when we look through this feedback, we can understand the calculation which was suggested in this model. In fact, on this picture, you can see the level of physical quantities which can be measured directly. They are indicated with rectangulars. Okay, there are valves. Okay, which specific meaning from system dynamic also, and there are errors and connection. The main idea that I would like just to give you the picture, okay, that everything is based on the feedback loops. Everything is based on the idea that the evolution is never linear. Okay, we can predict evolution when we take several factors, key factors, into account, and we'll calculate the dynamic of their interconnection. One example that was really kind of mind-changing for me, I'd like to share with you on the next screen. In fact, in those books, which was published in 1970, on the basis of the data, and using this is a part of the model, big model that I presented on the previous slide, but this is a part just about population, which is calculated just births per year, deaths per year, average mortality, average fertility. There is a reinforcing loop. There is the negative feedback, which put things into the equilibrium. But using this model, the team of researchers was capable to predict the population on the Earth 30 years in advance, almost 30 years in advance, with accuracy just 1 month. This is for me kind of, astonishing result, because they absolutely clearly stated when we pass 6 billion population on the Earth and 7 billion, and the accuracy just 1 month. For me, because on the table you can see results from statistics, okay? But if you compare with what was predicted in the by model World 3, you can see that the discrepancy is very, very, very small. When I saw this, I said, oh, if those models can provide us such accuracy on the basis of the limited resources, this is worth to be studied and worth to be used. So what? In fact, I'd like just to sum up my part of presentation and give the words to Bala, that any technology forecasting, this is a story about knowledge. Those who have knowledge don't predict. We don't need to predict about sunrise because we know when it will happen. But those who predict don't have knowledge. In fact, we are looking always about knowledge, and as soon as we have them, we can use them. What is interesting for me, because when I found those expression, it was said so many years ago, more than 2,000 years ago. It was already known more than 2,000 years ago. So what we are looking within this course, we are looking another way to get knowledge about future. And with a book of like Limits to Growth, we can be sure that it is possible. And this is the first barrier to believe, is it possible or not? Now I'd like to give the stage to Bala, and he will show you some details how system dynamics models work. Very in general, because this is by itself interesting topic. Yeah, please, Bala.
Okay, thank you so much, Professor Dmitry. I mean, thank you for introducing the topic to us. This is very, very interesting stuff, and I really enjoyed reading. First of all, knowing about this topic, and I thought, oh, this is one of those topics that probably does not have a lot of practical value initially when I heard about it. But when I saw that it is not only practical value, it has actually been applied not too far off, again, not in MIT, not in, I mean, the story that I heard was not in MIT, not in Europe, but right here in India. One of the chief ministers of a province in India, a state in India, by he's no longer with us, by name Parikar. He employed one system dynamics consultant to see how to effectively plan the expansion of a city in Western India. So that for me was, it means it's very, very powerful that decision makers at the highest level in our country at the administrative level are using it. So anyway, that's at that level. But let me start off with some very, very basic and practical examples, so that we get an idea of what this is, what are we talking about, just to get an idea of that. Just let me know if you can see my screen, and then I can start.
Yes, we can.
Okay, all right. So this is a interesting website. You can check it out for yourselves. There are lots of examples. We will drop the name in the chat, and ncase.me/loopy. That's the name of the website. It's interesting and easy to build as well. Okay, so what we have here is a model. So how system dynamics or limits to growth models work is that we have a simple model, and they operate in feedback loops. So anything and everything that we have in models is explained through feedback system. So here what we have are two such what are called stocks, and what is happening between the two is the let me just describe what we have here. The stock has cheese in it, and it has holes in it. Okay, cheese has holes in it. If some of the cheese, Swiss cheese for example, if you've seen it, has holes in it. Okay, so if the model simply says, and the positive and the minus just says that if the cheese increases, holes increase. That's what positive means, and the direction means. If holes increase, the minus indicates that the cheese decreases. Okay, this is as far as the model goes. Now let me play that. And what we can do, what you've just seen when I click the button play, is you can see that it's a variable. So when I take my mouse over it, you can actually change the values and see what happens. Okay, so let me just say, let's assume that the number amount of cheese increases. Okay, let's increase it. The arrow goes, increases the number of holes. Now that decreases the cheese. Oh, it's too fast. Okay, let me stop it. Okay, now if you want it slower, there's a speed button here which will take you to turtle speed, and on the right hand side is a rabbit or a hare speed, which is very fast, right? So let me slow it down, way down, and let's see. Cheese increases as a result of the amount of cheese increasing. Okay, that means the number of holes also increase, right? If you have cheese and there are number of blocks that we have, number of holes actually increases. But if the holes also increase in size, that means the amount of cheese is going to decrease. So if you have one big block of cheese increases, the number of holes increase, number of holes increase, then the cheese actually decreases. So it is shown by the size of the circle. Okay, now if I speed it up, you will see that is a back and forth. It keeps going back and forth, which means it's a balancing loop. The amount of cheese and the amount of holes actually take care of each other. Okay, now let's look at a little more complex system. What you can now see is knowledge. We've been talking about knowledge. Professor Dmitry introduced us to the last saying, which was, if you have knowledge, you don't need to predict. But if you are willing to predict, which means you don't have knowledge. Okay, let's assume I don't have any knowledge about, I don't know, skiing. Okay, I've skied once in my life, so I don't know anything about skiing. But in this particular case, let's say I'm a librarian, okay, and I want to I'm a researcher, let's say, and I'm wanting to find out about skiing, okay. So let's start here. Okay, what happened? Oh, it's going fast again. Let's go slow again. Okay, let me restart. I'm going to start again. So initially, I don't have much of subject knowledge. Now, if I learn about skiing, okay, now what happens to the keywords I'm going to use for searching skiing? Okay, the it becomes more relevant. Now I start looking for skis, I look for slopes, I look for inclines, slalom. So I start my keyword quality becomes better. When I use better keywords, look at what happens. The results quality also becomes more relevant, much more meaningful, right? So that's what you will see in the size of the circle actually increasing. Now, if the size of the circle which relevant results come and I read those, and hence my knowledge becomes better. That's what you will see in subject knowledge, and you will see that the circle actually increases in size. Now, if it increases in size, which means I'm now more knowledgeable about skiing, I know the angle of attack, I know how to brake, I know how to speed up, I know how a better inclination control, all that. The I know about all of that. Now the quality of search that I use, fiberglass, all that becomes even better than what I used to know about skiing, right? So what guess what's going to happen to my search results? As a result, that also gets better, okay, and my knowledge keeps increasing. So this is a what they call a positive reinforcing loop. What you saw earlier was a balancing loop. So the cheese and holes balanced out each other, but here it's a self-reinforcing loop. You keep getting better and better with time, because all of these loops are making things better with each other. Okay, so these are the two types of loops. You heard Professor Dimitri talk about it. There are only two types of loops that are used in the modeling. Okay, now we'll look at, just for fun, we'll look at no, this is not for fun, the last one is for fun. So this is a one where we will look at some of these loops. There are one loop here. So I'm sorry, yeah, there's one loop here, and there's one big loop. You will see. I'll switch it on, and you will see. So when we combine many loops, we form these models like this. And what you will see is, let's say the emissions increases. Oh, let me slow it down again to explain the model. Uh, I'm sorry. We should start. Let's say I'm driving. Okay, what is this a model about? This is about the interrelationship between driving, walking, and biking. And there's a safe streets, which is a variable also, and there are emissions as well. This is an incomplete model. You can keep building on it. Okay. If I increase the amount of driving I do, of course, the emissions is going to increase, but the safety of the streets is going to come down. Now, the safety of the streets is going to come down because there's too many people driving. Number of people walking is going to reduce, and number of people who are biking is also going to reduce. The number of people who are going to bike and walk are going to reduce. That is going to increase the number of people who are going to drive, which increases the emissions, and also the safety of our streets comes down, right? So talk about vicious loops, but this is a complex loop now, but we can understand what's going on. What is the relationship between these objects? So there's lots and lots of people driving, and there's hardly anybody walking or biking because of this factor, and the emissions are going. Oh, sad story. Okay, but we know this is mainly to understand, and with data also we can there are certain modeling tools that we can use, fit in data, and actually see if our understanding of the system is right or not. Okay, if it's not, go back and see if we have left out any variables, come back and fix the model, and see, and run the simulations again. This is how system dynamics essentially works, right? We take our model understanding of our of the system that we're looking at, and put it into a box like this with lots of loops, and that's how we simulate it, and we get our understanding. Is it correct or not? If it's not, go back, fix it. Usually it never is correct in the first go. We keep going back, fixing the model. Okay, that's how it works. Okay, the last one is going to be a flippant one. You heard me talk about Macbeth in the first one. This is just for fun, but I liked it all the same. So here is Macbeth's story, William Shakespeare's tragedy, Macbeth, and this is illustrated in the form of stock and flow, just how you would do system dynamics. And here it says start here. Let's see what it does. Let's do it slowly. Okay, if you know the story, which is first prophesize and tell Macbeth what he is going to become. Okay, okay, let me run it a little bit faster so as to see. And the prophecy is taking too long to get to Macbeth. There you go. A little faster. And Macbeth sees these three witches and he gets to know of the truth. Okay, guess what Macbeth is going to do? He is going to do a lot of things because he's a hero. He's going to do murder Lady Macduff. He's going to murder Macduff's child. He's going to murder Banquo. Oh, too many murders. So Duncan. And then tell about the prophecy. Of course, not in that order. He's going to tell about the prophecy to Lady Macbeth, who demands murder of all these people, which is why he's murdering all these people, and that spurs vengeance. And Macduff flees England, and Duncan, does whatever, names son their heir Malcolm, and then he musters Thanes, and then Thanes invade Macbeth. Ooh, so too many things. Just for fun, let's go full speed. Oh, look at that! Look at what's happening. Oh, this is amazing. Okay, this is your William Shakespeare. He must be turning in his grave looking at what I did with it. Okay, so that was fun. Have fun with loopy and system dynamics. I really love the modeling and what you can show to your kids as well. So it's fantastic. Plus, it's very useful in understanding the system around us, the environment around us, the system that we are working with. Okay, so this is a start. We can build as complex as what Professor Dmitry showed in his chart as well, with the same number of tools that we have. Okay, thank you so much. Over to you guys for asking questions about anything that's unclear in our course or anything that we covered today. Okay, thank you so much.
Yeah, thank you, Bala, for presenting us some concept of system dynamics through so many examples. But I suppose it gives flavor to our participants, how it can be applied in practice. There is only one thing behind of those model. In fact, we need to know what kind of factors to put inside of the model, and this is not also easy question to answer. But we are going to help you to answer this question within the second and third week. And we will also show you how logistic S-curve is connected with this modeling. Now, I would like to see, did we collect some questions on the shared screen?
Yes, sir.
Yeah, please.
We do have some questions from our learners on the live chat.
Yeah,
so
please.
I'll be happy to read out these questions on behalf of these learners.
Or you can put it just on the share screen, Siddharth, no?
Yeah, that will be better,
sure.
so that we can read the question as well.
Yeah, in this case, everybody can see what kind of question we are trying to answer. When Siddharth is preparing, I'd like just to answer something that I've seen. The link to the digital version of The Limits to Growth for the first book was published 1972 is fully available in the internet. We are going to share the link, and the 30 years later, only synopsis is available, but the book, the full version of the book is available in the libraries or in the bookstores. Yeah, please, Siddharth, can you share the screen with other questions?
Yes. So this is our first question, sir.
Yeah. Sometimes we can't invention become innovation. Why invention just stay invention and people don't cover it into innovation? Oh, thank you. Thank you for this question. This is a really critical question from point of view of technological forecasting, because whatever we are doing with technological forecasting, in fact, we try to answer when and how inventions will become innovations. And I'd like just to start with what you already probably seen in your course, in order to make this question crystal clear. The invention, usually, this is a new way to perform the same functionality with better performance. But what, as a society, we need the functionality with less expenses. So very often, the people who are very excited about solving some problem, they solve not exactly the problem which society need. You see, for instance, today, we really need to decrease level of pollutions, but we still use the same 120 years old technology to produce electricity. You see, we have millions of inventions about other topic, but we need to solve the problem which is critical. So that's why we need to forecast. If you look just to my screen, to the slide, this new transmission of the bicycle, even it is more performant, probably it will never appear as a product of certain factory. Why? Because those bicycles which already exist, the more critical for customers, not new kind of transmission, but no problem with their tires. So that's why the bicycle with without air, the tires without air, airless tires, they are more on demand. So we have innovation which answer the demand of society. So that's why more than 90% of inventions, okay, even from feasibility, they are possible as soon as they don't answer the demand of customers. And you can recall one of the video from the first week when one startup, they tried to develop a lot their product without asking customers what they need. Okay, this is exactly the result. This is a main cause why inventions, they are patented. It means they're feasible and they are well protected. They are ready to be produced. They can never be produced. This was my trial. Probably Bala has something to add for this question. Yeah.
Yeah, I'd like to say that yes, I totally agree with what Professor Dmitry just said. Is that invention is something that yes, the inventors saw that there is a problem and they've come up with some kind of solution. But and there are, like in nature, the solutions are plenty. There are many inventors attacking the same problem, trying to solve it their own way, and they have taken that next step of actually building something to make sure that it is indeed solvable. It is indeed solved. Okay, so that's the level at which they have attacked it. So that's where invention is. Sometimes resources of their own, sometimes resources from wherever they're working for, or something like that. So that's as far as invention goes. And some what what becomes, as Professor Dimitri and I keep discussing, is what becomes useful, what somebody else finds useful and starts using it, is when it crosses that barrier of it being just an invention to that word that we often use, thinking invention and innovation are the same, is when somebody else uses it and finds it useful, makes their life a little better than what it used to be. So that is the chasm that one has to cross, and when it becomes, in fact, even in a startup, as you're saying, it's great if the technology works, if the algorithm or anything, or even the basic prototype, everything works. This is great, but it's still at the level of invention. It's not yet crossed it, unless you get one person, one customer, one company, one user to work with it and say, yes, I did find this useful, I am going to use it. till that, it still lies in the realm of invention itself. Startup company, it's the same story, but since we started off with an example of a startup, I wanted to communicate that. And Siddharth, being a startup owner, knows this better than many of us. So he's also crossing the chasm. He knows how difficult it is to cross that chasm.
Right, right. Thank you for taking that question, Professor Dimitri and Professor Bala. Putting up the next question. Yeah.
Yeah.
Historical data is the basis.
Mhm.
Yes, sir.
Is the basis for
Historical
future.
data is the basis for future predictions
Mhm.
coupled with the insights. Still, why it fails most of the time?
Okay. Let me try to make it clear. In fact, the main barrier on the taking knowledge about future, this is what we believe today. And even looking to the same data, historical data, different people, they believe different things. Today we started with introduction of the book The Limit to Growth. In 1970, even 20 years after, those results were highly criticized. And a lot of people were disagree that this is, and very smart people, very intelligent people, were disagree with conclusion of those models. Okay. But what is really strange, that the output of these models, they are still actual. I mean, they're still working. You know, this is phenomena like, you know, imagine that you try to organize a party at the end of the week. But the weather forecast outdoor, okay, the party will be outdoor, very nice, okay. But the weather forecast is that it will be rainy. But the people, they don't like to believe this weather forecast because they would like to organize a party. This is one part of the story. Another part of the story, the people like to fight with the problem rather than to bypass the problem. So that's why they don't care about forecast. But the output, the results that we don't care about forecast, very often very expensive. And sometimes we even cannot solve the problem when it's already happened. Within my course, I share the example with my students about earthquake. If in the country you don't follow the standard of buildings in construction, which are earthquake resistant, when earthquake will happen, we will have a lot of fatalities. And there is no solution. Even all the world, all international help will arrive. There is no solution. The only solution is predict and to act accordingly. You know, the main barrier on the failure of prediction is not the lack of data. The cognitive inertia, the knowledge inertia that we have to manage. We, even me and other famous scientists, we all have cognitive inertia. It is not enough just to say, well, we need to manage cognitive inertia. How? And in body of our course, we try to share with you some models and some tools to manage this cognitive inertia, to reduce the subjectivity and to increase objectivity of our observation and our conclusions. Well, this was tried to answer shortly for this question. Even the topic is much more interesting. I suppose you can find some answers if you will look once again the video that we suggested in the first and second week about mental energy. Yeah. Did I answer the question? If
Yes, Professor, that sounds like a
still,
great answer.
I just
Putting
like
up,
to add something
yes.
to that, which is our favorite book again, Professor Dimitri, is a book called Factfulness by Hans Rosling. This is a solid book. It's again deals with psychological inertia, so to speak, our own mental models, and the fact how to use numbers and how to understand them in a certain way. So again, this is the classic conundrum, which is what you are probably referring to. Historical, we have data, we have our own mental models. So uh, you know, you can take numbers, live by that, and miss the big picture, or totally look at the big picture and not even see a single number, and get go completely in a wrong direction, right? So both of these could happen, which is what that book Factfulness is all about, is to how to merge these, how to be aware of the fact that we have mental models, we have ways of thinking, and there are numbers. How do you mix the two? And this, our course is also no different from that. We use models, and we use numbers, we use our own understanding, put it all together, and deal with that. Okay, so I would like to point it out to the word fail, used fail. Okay, predictions are not about failure. This is what I think I learned from Professor Dmitry, what, 8 9 years ago, is that we're not talking about failure or success of the prediction itself, but more about whether it's useful or not. So this is the main thing that we do with technology forecasts itself. So was it helpful in making a good decision, making a decision again and making, yeah, thank you. So that's what I'd like to add. Thank
Yeah.
Right. Moving to our next question. This is more of a continuation question to the previous one.
you.
Putting it up right on the screen.
How can you close or lessen the gap of error using historical data in forecasting? Okay, thank you for this question, because in fact this question is connected with the model that we already tried to start to discuss with you, because our course, this is introductory course. Everything can be learned through the practice, and we believe that in the future we will be capable to run the course which will be based on your project. But let me try to explain how we can improve use of data. First of all, the data that we select, we need to make clear how it is relevant to the question that we try to answer in order to support our decision. There is no good or bad data. There are relevant and not relevant data. Second, and when we treat the data, in fact, we need to understand what is behind of this data behavior. And so that's why today we introduce you just a little bit the system dynamics model with feedback loops, because it helps us to understand, for instance, why we had a growth, and after that suddenly it stopped, decline, and after that it's restart to grow. You know, when we look to the data, it is not enough just to take time series, to take certain function and to extrapolate the data. We really need to understand the process. So this is a way how we can close the gap. The second situation is when we take historical data, there another pitfall. Sometimes we take historical data for US and we try to make approximation for India. It's not a good idea. If we try to predict something in India, we need to find the data which are relevant for India. Is it okay? Because the technologies, the evolution of technology does not depend so much from investments, and they don't depend so much from inventiveness. The evolution of technologies depends on the social factors, knowledge factors, and other factors which interact all together. So that's why, what kind of historical data we need to take? This is an open question, and we will show you some insights in our second and third week. How can you select the data, and what are the pitfalls on this way? Did I answer the question?
Yes, thank you very much. Bala sir, would you like to add anything to it?
I would like to, if you allow me, I would like to answer the question that we collected even before our today's session, and this question about effectiveness and efficiency. Okay, and in this question, if I just to explain how did I get it, the idea is how to be effective as soon that within a dynamic in a real life, everything is changing very dynamically. And in fact, if you recall our video, and if you remember the man who tried to clean his car, and when he finished cleaning the car, he just realized that this is another car that he should clean. Okay, and in this question, the point is, in real life, how to know what is our car, because it's changing dynamically, and some competitors arrive, and so on and so on. Well, in order to, in fact, what companies are looking for, the companies are looking for to be both efficient and effective. With efficiency, there are a lot of methods. Okay, the lean manufacturing and the lean design and other things today are kind of buzzwords, or they're applied all around the world. So how to be efficient? It's not so big question. How to be effective? Because most of the people believe that everything is changing every day, but it's not something that we can observe from the reality. And what happens very often, we look not at the right direction. Let me illustrate with a slide what I mean that we look not at the right direction. Today we are discussing a lot about production of electricity and how it is efficient. We are burning coal, we are running nuclear power station, we are trying to install solar panel, we do a lot of things. But in most of the cases, we don't look at another part of the story. On this diagram, what you can see that efficiency of using energy in United States, and this diagram very similar for most of the countries with GDP per capita, similar like United States, you can see that the 69% of energy produced, they are rejected. They are rejected. This is something very, very strange to see. We can improve efficiency, for instance, the solar panel, we can improve efficiency of producing electricity by hydropower station, nuclear, enormously. But if you look their contribution to electricity generation, and we look to the rejection, we need to start our journey about efficiency and effectiveness from another side. We need to find a way how to reject less energy. In India, we do the same. We reject a lot of energy. In France also, because this is a way how do we use it. So when we are talking about effectiveness, the whole topic of technology forecasting, this is in order to answer the question how to improve effectiveness. Because if you have a reliable forecast, it's like the weather forecast, you see? You know that in 3 days you will have this. You can be effective with organization of your party. You can just cancel your party 3 days in advance, so you don't need to spend a lot of resources. This is exactly, so that's why I appreciate this question that in real world, it is difficult to be effective. Yes, it is. Why? Because we have no reliable forecast. So we suggest you the course, how to be more reliable with your forecasting in order not to be only efficient, but effective also. But don't forget that when we are talking about efficiency, in this case, I tried to also to answer another question that we received in the forum. We need to look not only from technological point of view, which is in the left part of this slide, but we have to look to the right part of the slide. Also, to how do we consume? What is the efficiency of consumption? And the reason of so high rejection is very simple, because electricity, we have no good solutions to store electricity. The batteries, this is a very minor, very tiny piece of the story about energy. The batteries, they are not real solution. When we produce electricity, we have to use it in the same time. Otherwise, it will be just rejected. It was my trial to answer for your question. I hope it was useful. Yeah, do we have other questions from our audience?
Yes, sir. Yes, Deficiency, sir. We do have another question. Right.
Yeah. So in service industry, what are the examples of inventions and innovations, or does it work only in the case of goods? Yeah, I do appreciate this question. Let us see carefully. One of the iconic invention, which people are talking when they start to talk about invention innovation. For instance, suggestion of iPod by Apple at a certain time was recognized as a revolution, as invention, disruptive innovation, which changed everything. But if you look carefully, in fact, the MP3 players already existed before this very small and very funny device. What was really invented by Apple at those time, they invented new service, the new service to sell music, because at those time, normal way was to buy music on the CD, and on the CD we paid in Europe €1 per song. Okay, so if you have 12 songs on the CD, you have to pay €12. What was invented by Apple at those time, you obtain the same number of songs, 12, but not for €12, but for €6, 2 times less, 2 times cheaper, 2 times cheaper. In fact, everybody believed that Apple invented iPod. No, they didn't. What they invented the service. They invented the service where legally we can go and we can download high quality music. So in our examples, we are going to share with you the story about music recording for our future lectures. And we will see how, in fact, whatever service we are talking about, it is connected with some new features of goods, and vice versa. There is no new goods without new kind of service. If we just take them separately, we limit ourselves on understanding of the process. And the system thinking, what we try to convey within our lectures, you try to see the all together. Let's imagine you try to sell new kind of personal mobility device, okay, new kind of scooter. But if behind of this scooter you have no maintenance service, if you have no service of recycling, it doesn't work. Because the first people who buy this scooter, they will face that some tiny part was broken, but they have no idea how to repair it. They will just abandon it. You see, so that's why for me, with my limited experience, probably I'm wrong. Let me check. That whatever kind of service we invent and promote, this is always connected with the products and goods and vice versa. And was it answered for your question, or you're still in the doubt about? Is it okay?
Yes, Professor.
Let's just see also, yeah. Thank you for the answer.
And we are just about time for our session for the day. I hope our learners had a very interesting session and they got their answers for the answers they were looking for. And I'd like to thank Professor Bala and Professor Dmitry very much for having this live session with our learners. And final words, Bala sir, over to you.
Okay, thank you so much, Professor Dmitry, Professor and our own Siddharth for anchoring this whole show, so to speak. And thanks everybody who's watching and who's been asking us some great questions. This is exactly what we were looking for. In case of any other questions that we have left unanswered, please feel free to use the discussion forum. We'll be happy to answer there, or wait till the next session. If you can hold off till the next session, we'll meet again. I think in a week's time, Siddharth, where we will reconvene and you can ask these questions live to us. And rest assured, we will answer your questions, all of them, to our best of our knowledge. Thank you so
Yeah.
much, everyone, and particularly Professor Dmitry
Yeah.
and
And
Siddharth.
do not hesitate to put them into the forum. In this case, we will
Yes.
prepare them better. Thank you very much.
Right. Thank you guys. Have a great day.
Okay, thanks everyone. Bye. Bye.
Bye bye.